Good day everyone. In this video we are going to learn about logarithmic function. What is logarithm? What is logarithmic function? Is it also part of exponential function? So let's try to learn about logarithmic function in this video. So logarithm is a quantity representing the power to which a fixed number, the base, must be raised to produce a given number. So let's define, or let's give what are the properties and what is the formula for logarithmic function and what is the relation between logarithmic function and exponential function. Okay, so logarithm, we've discussed exponential function, which is y is equals to b to the power of x, where b is greater than 0 or b will not be equal to 1. But what about solving the same equation for y? So now we will use logarithm of x to the base b, which is y is equals to log or logarithm x base b if and only if. Okay, so x is equals to b raised to the power of y. So when you can see the formulas there, you can observe that logarithm is the same as exponential function. When you're going to solve logarithm, you can convert the function into exponential function first, so that it's easier for you to solve for logarithm. So here you can see we have base b raised to the power of y and then equals to the value of x. Okay, so when you are going to solve for logarithm, so you have to convert to exponential function to make it easier. Let's try to explain a little bit more further so that it's easier for you to understand. So there are two different type of logarithmic notation. So we have the common logarithm and natural logarithm. So when you can see logarithm x, it is always base 10. If you cannot see, there will be a base there. ln x is equals to log x base e, or it is written as log. We have x, we have base e. You're going to write that one into ln x. What are the properties of logarithm? So we have the laws are log mn base b is equals to log m, okay, base b plus log n base b. We have log m over n base b is equals to log m base b minus log n base b. And then we have log m to the power of n, so we can have now n log m base b. And then here we have log 1 base b is equals to 0. And then log 5 or log b, the number 5 here, log b base b is equals to 1. And then if both we have logarithm have the same base, we can solve directly for the value of x. Okay, so when you observe here, we have to convert this one, right? Why it becomes logarithm equals log 1 base b equals to 0? Because when you're going to convert that one, the base is equal to 0, right? I mean the base is b and then raised to 0. Therefore, it's equals to 1 because any variable raised to 0 is always equals to 1. Going back to multiplication, when you're going to multiply, we have in the laws of exponent, you are going to add the exponent. It's almost the same here in logarithm. So you have am times an. It will give you as am plus n. So exponential, or the loss of exponent and loss of logarithm, is almost the same. Same as here in quotient or division. So you have am divided by an. It will give you as well am minus n. Okay, so and then the last part here, which is b the base, okay, b the base raised to the power of 1, it is also equals to b. So that is, we have the properties or the laws of logarithm. So let's try some example. So from logarithmic form to exponential form. So if you can see here, we have log x base 10 equals to 2. So therefore you have the base, okay? So you have the base, you have the exponent, here, and then you have the value of x. So you have the base, you have the exponent, and then you have the value of x. So that is how you will convert now a logarithmic function into exponential function. Let's just skip the second one and go to the third one. So ln x is base e, right? So we have the log, or ln x is also equals to log, okay, x base e. So therefore we have the base here is e, the exponent here is 2, and then we're looking for the value of x, which is this one. Okay, so let's try some more example. So how we will solve now logarithm of x base 3 and then equals to 4. So how we'll solve for x? So therefore we have now base exponent, so it will become up as 3 to the power of 4, which is 3 times 3, right? We have 3, okay, 3 times 3 times 3 times 3, which is we have 9 times 3 we get 27, times 3 we get 81. So that is how we get the value of x. Next one, logarithm of, we have 4 base 16 to the power of x. So what is x now? So we have the base, we have the exponent, we have the 4. So therefore what you're going to do is we have 4 equals to 16x. So we will try to factor what are the common factor of 14 and 16. The GCF, greatest common factor. So we have 4. So therefore both of them now have the same base. So therefore we can solve for the exponent. So therefore we have 2x equals 1, x equals 1 over 2. So when you have the same, we have common base, we can get directly the values of the exponent. So which is the 1 and 2x, which is 2x equals 1, because the sign here is we have equals. Next problem. How about log 8 base? We have x and then 3. So now we are going to solve for the base. What will be the base for x? So therefore you will have now as 8 equals to 2 cubed equals to x. So therefore we have to try to make, because when you're going to convert that one, it will become x cubed equals to 8. So we will try to find what will be the factor of 8 that will get, we have an exponent of 3, so that we can get the base. So therefore you have 8 is factored as 2 times 2, 2 times 4, and then after that one 2 times 2. So therefore 8 now is equals to 2 cubed, and then we get the same base now. So therefore you will get as here. So we have x cubed equals to 2 cubed. So therefore this one have the same exponent, so the value of x is here. So this one will be our x. Okay, so let's just go to, we have some applications of the properties. But when you're going to solve for the logarithm, if you have your calculator with you, it will give you the approximate, we have given values. This one is 4 decimal places. So logarithm of 2 is equals to 0.3010. Logarithm of 3 is equals to 0.4771. Logarithm of 5 is equals to 6990. So if you have your calculator with you, you can try what is log 15. So when we are going to factor, the given here is just only log 3, log 2, and logarithm of 5. So we can factor 15 into 3 times 5, so that we can get we have the given, we have logarithm. So therefore we have 3 times 5, and then after that one, these are the equivalent of logarithm of 3 and logarithm of 5, and then basically you are going to add, because we have, if it is m times n, logarithm of m, n, you will have log m plus log, we have n, which is this one is our m, this one is our n, and when we are going to add that one, and then we get this value. But if you have your calculator with you, you try to press only logarithm of 15, and then you will get the same result. Okay, let's try to solve this equation involving logarithm. So log, we have 4x minus 5 base 6 equals to log 2x plus 1 base 6. So basically here you have the same logarithm, right? We have log 6 here, base 6. So therefore you just go for 4x minus 5 equals to 2x plus 1. And then we will convert it to 1, or we find the value of x. Find the value of x, so we will have now as 4x minus 2x equals to 1 plus 5, which is 2x equals to 6. And then now x is equals to, we have 6 over 2, which is equals to 3. Okay, so that is, we have the value of x. Let's try another example. How about the second one? So we have logarithm of 5 plus x. So we have this one here, have open and close parentheses, equals to 3, and then the base is 4. So therefore, we will try to convert everything into exponential. We have function, which is the base is 4, the exponent is 3, and then equals to 5 plus x. So 4 to the power of 3, which is 4 times 4 times 4. Okay. So we get this one. So let's just continue this one. So this one is clerical. We have the error of the pen. So we have 4 times 4 equals to, we have 16, and 16 times 4 is equals to, we have 64. So therefore your equation now will give you 64 minus 5 equals to x. So x is equals to, we have 59. So in solving, we have exponential function or logarithm function. You have to check every time. You have to remember what will be the properties so that it's easier for you to solve the exponential and the logarithm function. Let's try the last example. So we have ln x squared, square root of x squared minus 1 divided by ex. So the properties that we're going to use is property number 1, which is the addition. We are going to add, because this one is multiplication of 2. We have different variables, or different, we have given terms, over e to the power of x, which is division. So therefore, we have now as ln x squared over x squared minus 1 raised to the power of 1/2 over e to the power of x. Okay, so ln, so you have to addition, add it 1. Property number, we have property number 1. Okay, property number 1. This one here will move to property number 2. And then after that, because we have the x squared, so you move x squared in front, that will become 2 ln x. And then 1/2, because square root of x squared minus 1 is also equal to, we have this 1 over 2. Okay, and then after that one, we have to find ln e, because you move x in front, so that is x ln e. And then ln e is equals to 1. So therefore, we have this one as our final answer. So if you have clarification and question, don't forget to comment in the comment section below. And then if you have something to ask for about mathematics, just comment below. Thank you so much and have a nice day.